We're going to finish up transformations today. What is this? Section 1.6c of the notes. Finishing up transformations today. We left off yesterday with a sneak peek for today's stuff. And what I did was I gave you a quadratic, right? And if I remember correctly, it had 5 different transformations in it. And I don't think I said that yesterday, but I'm pretty sure the one I wrote for you had 5 transformations. And what I asked you to do was just think about the order of those transformations. So if you had to describe to me those 5 transformations, in what order would you say them? And yes, actually, it does matter. And we saw that yesterday with the last example where when we switched our vertical shift and our vertical stretch, when we switched them, we got completely different equations, right? So obviously the order in which we describe them matters. Again, we're going to continue to sneak peek our way there, and we'll see if you guys stumble across the method in which you describe them. So right here, I drew some generic random piecewise function. It's a piece of a circle and piece of a straight line. I'm telling you that is f of x. And what I want to do is transform it according to 2f of x plus 1 quantity minus 3. That is 3 transformations. Which one of those 3 transformations do you think we should do first? It's okay, say something. Anybody, say anything. Horizontal. The horizontal one? Okay. There is only one horizontal transformation. We can do that one first. Dirty little secret, it actually doesn't matter in what place you do the horizontal transformation. Is that always the case? No. But for this one, I could do that horizontal shift of left 1 unit. First, second, or third, it won't make a difference. Why, Mr. M? Well, because there's only one horizontal transformation. No y changes, which the vertical stretch factor 2 on the outside and the shift down 3 units on the outside, no y changes can ever affect the x's. So it doesn't matter when we shift left. We will always get the same result from that transformation. So we can do that one first. I mean, let's go ahead and do that one first because that was the loudest answer. Let's shift left 1 unit. So this one, let's see, good notes. This is shift left 1 unit. All right, so let's take that image. Oh, by the way, I'm going to do this thing the hard way first. And then I'm going to show you what I think is the easy way. Shift left 1 unit. All right, let's see. I'm going to do this as a dotted line. You guys cool with that idea? So this point moves to here. This point moves here. This point moves here. And I'm going to do my best to... There, we have shifted left 1 unit. Now there are 2 vertical transformations, vertical stretch factor 3 and shift down 3. Which one do you think has to be done first? Because it does matter. You have a vertical stretch of factor 2 and a shift down 3 units. One of them has to be done first, but which one? So both of you said the shift. Does anybody disagree? Okay, Holly disagrees. Now here's the reason why I ask, is because I'm not just going to let you guess. I'm going to make you justify why you think that's done first. So gentlemen in the back, they're over there patting each other's backs. They think they're right. A justification. Why do you think we should shift down first? Because the vertical stretch will affect the y, yeah. But won't the shifting down also affect the y? Yeah. Okay. So why is one effect more important than the other? The shift to the stretch is going to depend on the new y value. So you're thinking that the stretch depends on the y value that the shift will give you. Okay. Holly, do you have any justification why you think you should do the vertical stretch first? I don't know. She doesn't know. You guessed. Yeah, I just wanted to disagree with her. She just wanted to disagree with you.
I think I can help Polly with hers.
Okay. McKinley, what do you think?
I think the reason you do the vertical stretch first is because when you multiply it, because it's on the outside, you
Hmm.
multiply it by everything,
Right.
including x and whatever -3 would be.
Well, not the x,
So
but
if
yes.
-3 was there, then it already there, then it would also be multiplied by 2, which would make it -6, which
So what
makes
she's
sense.
saying is, in case you couldn't hear, because the speaker points at me so I can hear very well, is if the shift down 3 happened first, then the vertical stretch would have had to have distributed across the entire thing, which means your shift down 3 would have become a shift down 6. Now, that would have been the result. That is a right answer. It's not the easy right answer I was looking for, but it's exactly why. So, a moment ago, Ashley, you raised your hand. Did you have an idea? You were going to say the same thing? I mean, it is a right answer. It's not the easy, low-hanging fruit right answer, but it's definitely right. Okay, what do you got for me? Brooks, why would you multiply first? Oh, PIMDAS, that's right. Yeah, you see, the order of transformations on the outside follows PIMDAS. Multiplications have to come before addition and subtractions, and the reason why for transformations is what McKinley said, is because if the shift down 3 had happened first, the multiplication would have affected that and it would have become a shift down 6. But the easy answer was PIMDAS. Yeah. So we actually have to do, we actually, we actually, hey, correct is correct. A win is a win, and Holly's a winner today. Okay, so, alrighty, so we are going to do a vertical stretch of factor 2. Vertical stretch, factor 2. Wow, this is awful handwriting. Vertical stretch, factor 2. So vertical stretch, factor 2, let's see. This only affects the y's, right? Well, my x-intercepts have a y value of 0, so that's not going to change. I'm just going to go ahead and put those dots there because we know that won't change. This will also be dotted. And the y value of positive 2 is now going to become a y value of positive 4. So let's see, dotted. Like that. And lastly, and I know I did it in purple. I mean, I did it in green, but I'm gonna do it in purple now. Whoop, squeeze it in there like that. This is gonna be shift down 3, which is going to result in, and this time I'll do a solid one. This point, 1, 2, 3 goes here. This point, 1, 2, 3 goes here. This point, what happened? Here it goes. 1, 2, 3 goes here. And we're gonna get this bad boy. Ta-da! Good. Now, that was kind of a pain in the butt, though, wasn't it? Had to draw that image 3 different times. Didn't it kind of bite? I mean, I didn't like doing it. Part of the reason why is because I am not a spatial thinker. It's tough for me to move things in my mind. It really is. I'm not lying. I can't even follow a map. Oh, a map is this thing that we used to use. You would unfold it. It's made out of paper, and it would tell
Know
you
what
which.
maps are.
Oh, you do? Oh, okay. I didn't know because they don't exist anymore.
They
That,
do.
no,
They
no, no, no,
have
no,
the
no, 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 because Google Maps turns for you when you turn. That's not the same. You see, a paper map,
But it is the
when you
same
hung
with
a left, the
amusement
paper
parks.
map didn't turn
They
unless
get out
you
of the car.
turned it. Okay, lazy. Anyway, but my
What about
point
the
is,
things they get at the beginning of amusement parks? Like,
yeah,
isn't that
okay,
what
amusement parks. That's right. Okay, occasionally you get to see one. How long until there is a Disney World map app? I'm just saying.
I
There
think
already
every
is. Dang it! I got to keep teaching. It's not going to be my check it out of here. I thought I had $1 million idea. Well, anyway, I'm not a spatial thinker. I'm really not. It's not a lie. I'm bad with spatial math. So to pull off these 3 transformations in my head would have been near impossible for me. Luckily, transformations are algebraic, not just geometric. And I am going to show you the algebraic way to transform things. Let me write down my original x comma y as a t-table. I know that seems kind of childish, but trust me. My original xy's, and I'm just going to go from left to right, were -2 comma 0, and then 0 comma 2, and lastly, help me, there it is, 4 comma 0. We had one horizontal transformation, correct? And I'll go ahead and stick to the purple color because that was the final answer. One horizontal transformation. Shift left 1 unit. When you shift left 1 unit, what happens to all of your x values? Oh yeah, you subtract 1 from the x's. So basically you take your x's and you go -1. So now my new x values are -3, -1, and 3. And as long as you can follow the order of operations, in order to pull off where the new y's are going to be, you literally, oh, look at this, I just forgot to write there, I forgot to write factor 2. You literally multiply the y's by 2 and then subtract 3. So you just do 2 times your y value minus 3. So 2 times 0 minus 3 is -3. 2 times 2 is 4, minus 3 is 1. And 2 times 0 minus 3 is -3. And those are the coordinates of the final transformed image. Ta-da! Look how much faster that was. See, transformations are algebraic. Transformations don't change a graph. Everybody thinks that a transformation changes a graph. No, it doesn't. Transformations change the coordinates. But when you connect the dots, you get a new graph. And that's why I didn't use a standard polynomial or something like that to demonstrate that concept. This is so much easier in my mind to follow a string of transformations. You just ask yourself, what are you going to do to the x's? Do it. What are you going to do to the y's? Do it. Plot the dots and connect them. Done. So much faster than drawing 3 new images, at least to me. If you can pull off multiple transformations in your mind because you're a geometry person, good for you. You go for it. I'm not going to do that. That's hard, for me at least. But do you like this algebraic method, or have you seen it before? Crickets. Okay. Well.
No, but it's good.
Oh, I didn't even realize that there was another grid down there for me to do my work on. Well, whatever. Whatever. I'll be okay. You would have mentioned it if you were paying attention? Gotcha. Okay, so order of transformations. Vertical changes. We've already figured this out. The vertical changes, according to Brooks, and he's absolutely right, follow PEMDAS.
What's PEMDAS?
Please excuse my dear Aunt Sally. You know the order of operations.
Oh, I didn't realize that it was pronounced like PEMDAS. I never spelled it out. I just always said, please excuse my dear Aunt Sally.
Oh, yeah, it's just PEMDAS. It's the order of operations. They follow PEMDAS. And you know why? You know why they follow PEMDAS? Because Y changes do the things that we think they should. See how my Hiovas still works? And that's because Y changes do what we think. Now, yesterday's sneak peek, if you remember back to the quadratic I gave you, there were 2 different transformations inside those parentheses, weren't there? There was a number in front of your x, which is a horizontal stretch or shrink, and then there was also an addition or subtraction in there, which would be a shift left or right. What do you think the order of transformations is on the inside? Backwards. And why would it be backwards? Right, because x's do the opposite of what we think they should. So if you have multiple transformations on the inside and you have to describe them or you have to do what they tell you to do, you do them using the opposite. So you wouldn't follow PEMDAS, you would follow SADMEP. No, it's PEMDAS spelled backwards. Well, SADMEP, every time you solve for x, you're using SADMEP. Every time you solve for a thing, did you realize that you were undoing the order of operations? Did anybody ever describe it to you that way? Anytime you're solving for a variable, you're doing the order of operations in reverse. It's always SADMEP. Anyway, and this is because y changes, or x changes, excuse me, do opposite. Hiovas. Horizontal, inside, opposite. Neat, huh? So yesterday's sneak peek, I believe I put a -2 on the front of your quadratic. That's 2 transformations. One is a negative sign, and one is a 2. Here's the nice thing. They're both technically multiplications. So which one of those 2 you do first? Unimportant, because they're both multiplications, and order of multiplication doesn't matter. As long as the multiplications on the front happen before the addition and subtraction at the end, you're good. And there were 2 transformations on the inside. I think I wrote like 2x plus 4 or something like that on the inside. you would have to follow those in reverse.
It was 3x minus 2.
3 on the inside? 3x minus 2? So you would do you would handle the minus 2 part first. So the first thing you would do is you would shift right 2 units, and then you would perform the horizontal shrink of factor 1/3. Yes, sir.
So are you saying you basically go like letter by letter? You do like P and then P for vertical and S for horizontal, and you just move down the line?
Yeah. So if you're looking at Y changes, you just follow the order of operations. I mean, let's be real. The operations are either going to be a multiplication of some sort or an addition subtraction, because technically a reflection is multiplying by -1.
And you do all of like horizontal and vertical, or do you do them at the same time?
It doesn't matter. You can do the horizontal changes first or the vertical changes first, or you could go back and forth, vertical, horizontal. It doesn't matter, because vertical changes never affect the x's and horizontal changes never affect the y's. The only thing that matters is that the order of your y's follows the order of operation. The order of your x's does the order of operations backwards. That's all that matters. So that's why I said for that one just a second ago when we shifted left one, I said you could do it anytime you want. You could have done it first, second, or third. It wouldn't have mattered. You still would have got the same answer because that was an x change and it can't do anything to the y's. They don't play with each other. Is that it on the page? Is that it? Done? Okay. Catch up with me, panel. Thank you. So describing and or performing compositions of transformations. I want to use the parent function, f of x equals x squared. And a whole bunch of transformations have happened to it to give me g of x, which is negative, and then quantity 3x plus 1 squared plus 4. And I want to describe the transformations that were performed in order to turn my parent function into that crazy one over there. You have 2 transformations on the outside. You have 2 transformations on the inside. And because it doesn't matter which ones I do first, horizontal or vertical, and because it doesn't matter if I do horizontal, vertical, or vertical, horizontal, vertical, horizontal, it doesn't matter. What I'm going to do is I'm just going to list the transformations as, whoops, I didn't mean to write x, horizontal, and we'll list them in the appropriate order for horizontals, and verticals, and we'll list them in the appropriate order for verticals. There are 2 transformations on the horizontal. There are 2 transformations on the vertical. And we just make sure that we follow them in the correct order. I wrote horizontal first. Hi-yo. Boss. Horizontal, inside, opposite. So which part of the inside do I have to describe first? The 3 or the plus 1? Lots of people. That's 2 people. The plus 1, because the order of operations in reverse. The plus 1 must be described first. So x plus 1 is what kind of transformation? On the inside, if you see x plus 1. 1 unit to the left. So it's shift left 1 unit. And after the shift left 1 unit, then you would describe what that 3 is doing. That is a multiplication. All multiplications are stretches or shrinks. Inside changes are opposite, though. So we describe that as a stretch or a shrink. Shrink factor of what? Very good. So we have a shrink factor 1/3 because you use the reciprocal. Awesome.
Shouldn't the shrink factor have been first?
No, because it's an inside change. And inside changes have to follow the order of operations in reverse because the inside does the opposite of what we think it should. So we do the plus and minus first and then the multiplication when you're on the inside. But outside changes do exactly what we think they should. Vertical, outside, same. They follow the same order we think they should. So that means multiplications first, then addition, subtractions. And that negative sign is a multiplication. It's multiplying by -1. All negative signs are reflections. So since this is a vertical transformation, am I reflecting over the x or reflecting over the y? Lots of voices. And everybody said reflecting over the y. It's x though, because the y-axis is up and down, and if you reflect over it, that's a left and right motion, like this. In order for it to be a vertical change, you must be reflecting up and down, which means you're reflecting over the x-axis. And then the +4 on the outside. Addition and subtraction is always a shift. Outside, same. So is that shifting up or down? Up. So shift up 4 units. There you go. So that is an accurate description of how that thing is different. It goes take your parent function, shift it left 1, and then horizontally shrink it by 1/3. So now it's 1/3 as wide. Then turn it upside down by reflecting it over the x-axis, and then, that's right, shift it up 4 units. You could have done the vertical ones first, and then the horizontals, wouldn't have mattered. Same answer. So remember a minute ago when I said that I don't do spatial mathematics? I don't. It's not a lie. I would rather look at a transformational rule and ask myself, what is it doing to the coordinates? For example, let's just assume that point P, being at 1, -2, is on my graph. I don't know what the equation is, and I don't know what that picture looks like. I'm just telling you 1, -2 is on it. I would like to know, what are the coordinates of its image? Meaning, where would that point be after, or where would that point be on this curve? Meaning, after you had done all of this stuff, where would that point have landed? Now, I will say that there's a typo on my notes. It is right here. That little exponent should not have been there. That doesn't make any sense. Exponents are not transformations, and that is a transformation rule. What happened was I was copy-pasting, and I copy-pasted a structure that had an exponent by accident. So just scribble that bad boy out, okay? Mistake. There. I see 1, 2, 3, 4 transformations that have been performed. The point is 1, -2. There are 2 transformations on the x. Which one do we have to deal with first? The 1/2 or the -2? -2 has to be dealt with first because it is the order of operations in reverse. Now here's my question. If it said just f of x -2, what was it telling you to do? Yeah. F of x -2 tells you to go right 2. And if you shift right 2 units, do numbers get larger or smaller? They do get larger. Then, if it had just said f of 1/2 x, what was it telling you to do? How about this? Before you try to say the word stretch or shrink, describe the factor. It's a factor of 2. So is that a stretch or a shrink? Stretch. The words never lie. The function notation lies. If you're going to multiply something by 2, you're making it larger. That's why I said the number's 2. You go, oh, that's a stretch. So this is a horizontal stretch factor 2. So this is a stretch factor 2. And when you stretch something by a factor of 2, what do you do to the number? Yeah, you multiply by 2. So the new point, which we'll call P prime, if you remember back to your geometry days, once you transformed a point, its image had a prime on it. P prime says, add 2 to your x value. Now I'm at 3. Then double it. 6. And now we can do the transformations on the y value. Y changes do exactly what we think they should do. That means they follow the order of operations. So what's going to happen first? The 4 on the outside or the +5? The 4. So I have a 4 f of x, what is that telling me to do? Multiply y by 4, and if you had to describe that in words, vertical stretch. So this is a stretch factor 4. We already know it's vertical because it's no y's. That looks like stretchkaba. Let's try again. Come on, board. Come on. You can do it. There we go. Stretch factor 4, and you've already told me has the same effect, so it is going to multiply that number by 4. And then lastly, the plus 5, what is that telling me to do to the number? Well, that's the shift. Yeah, the shift is shift up 5. Oops, I forgot to write f of x plus 5, and this is shift up 5. Yes, which is adding 5 because outside changes do exactly what we think they should. So the first thing we're going to do that negative 2 is multiply by 4. Now we're at negative 8. Negative 8 plus 5, negative 3. So if the point 1 comma negative 2 was on our f of x, then the point 6 comma negative 3 is on our g of x. Neat, huh? You don't need the graph. You don't need the equation. Transformations don't change graphs. Transformations change coordinates.